we filming?
Yep.
Okay. So we blew up the balloon, and the circumference is 28 inches.
Okay.
So right here, we solve for the circumference. We have 2 pi r equals 28, so we divide it by 2 pi, which would be 14 over pi, which we solve for, which is roughly 4.456. And then we plug the radius into the volume formula, which is 4/3 pi r cubed, and we solve that to be 117.997 pi equals the volume. So what we're going to solve for is the surface area is changing when the volume equals x. So first of all, we're going to find the rate that the volume is changing by letting go, and Isaac's going to time it. So, okay, say go when you're ready.
Ready, set, go. 2.23 seconds.
So 2.23 seconds.
Okay.
Okay. So the time that it took for the balloon to deflate was 2.23 seconds. And so we want to solve for V prime, which would be the volume when it started out divided by the time. So we'd be solving for, cubic inches. It is losing a second. So the volume was 117.997 pi. So we divided it by the time, which is 2.23 seconds. And we found that V prime equals 52.913 pi inches cubed a second. And then we plugged all that into, then we found the volume for the sphere, and we took the derivative of it, which would be 4 pi r squared dr over dt. And then we plugged everything into that, and V prime equals 52.913 pi. And we're solving for dr dt when the radius equals 3. So we plugged in 3, and we solve that, which would be, so you just divide by 36 pi. The pi's cancel out, and you get 1.47 inches a second is the rate the radius is changing when the radius is 3.
Okay. Go.
Okay, so since we wanted to figure out the rate the surface area is changing, we had to plug it into the surface area equation, which is 4 pi r squared. So 4 pi, and the radius was changing at a rate of 1.47 inches a second.
Approximately.
Approximately, yes, of course. So we solve that, and we get it to be approximately 27.155 inches squared a second. So when the radius is 3, the surface area is changing at a rate of 27.155 inches squared a second.